My name is Nick Venner, and I'm on the Greenbuild team. Before we dive in, I have a few quick items to go over. First, if you're experiencing any technical difficulties, audio issues, video problems, anything like that, please refresh your browser. That usually takes care of most of the issues. If problems persist, our support team is standing by to help. Second, we'll have a Q&A session after today's discussion, so please don't hesitate to submit any of your questions throughout the presentation. You can use the Q&A section in your webinar interface to submit any of your questions, and we'll be monitoring them closely. Our panelists will try to address as many of them as possible at the end. Now, that we have all that out of the way, I'll hand it over to our speakers to get started. Kimon, the stage is yours.
Thanks, Nick, and thanks Greenbuild for having us here. One quick comment is we all are going to be at Greenbuild in New York at the AI Summit. This is part of the team. So we're giving a sneak peek at it, but more importantly, we're showing how we're preparing for that. We're actually showing the workshops that are happening weekly now with a lot of teams around the world, and it's pretty exciting to bring this to Greenbuild. So let's get started. The team today is Stephen Lothrop from PAE Engineers, myself from Onuma Inc., Tristan de Frondeville from SkyCentrics, and Zahra Ghorbani, who is going to be starting at Massport pretty soon. And it's about meeting the new building team. So this is part of the building team, but there are AI agents in the background. It's about people and agents working together and buildings talking. And we're going to be heading towards how do we measure the building and how is LEED version 5 even used for this. A lot of moving pieces, but we're going to break it apart piece by piece, and there's a lot more to come after this webinar as well. So coming as an architect coming from the building industry, I know that there are challenges. We all know there are challenges. There are different documents, files, spreadsheets, PDFs, information about buildings, LEED checklists that we used to or still do fill out to get that platinum rating. But in the middle of all this, there's information and intelligence. The intelligence is in the design and construction process. And that's I call it a underutilized resource. It's a resource that if we don't use it efficiently, it kind of goes poof and goes away. So even if the building is done, what do we do with it? And that's what this is really all about today. How do we capture that and keep it alive during the design of the building? So I start with this slide because I've been going to sessions talking about digital twins, and people say, "What is a digital twin?" And I say, "Well, this is my digital twin. It's my heartbeat right here. My heartbeat is saying I'm alive. There, I have a heartbeat. That's good. It knows where I am, and my phone knows all my statistics for where I walked the day. It has a map showing where I am. It has a phone number that's a unique ID that anybody can call me no matter where I am in the world. There's a standard called international codes for phone numbers, right? Nothing complex. But if we don't have a heartbeat and we don't have a location and we don't have the technology, we can't find out what we're doing. And there's a lot more to this. This is not my only digital twin. There's other parts of me that are out there that in the world. The reason I bring that up is we are overcomplicating, I think, in the industry what a digital twin is for the building industry. There's a lot of confusion about what is a digital twin and what's not a digital twin. Whose digital twin is it? It's really a system of systems and the ability to talk to the building and have the building talk back to you, which is really exciting because the technology has been here for years. We just don't have it yet in the building industry, which means it's the right place to use it. And Tristan and others are going to be showing some pretty exciting stuff of how we talk to the building. But let me start with this slide. If you walked into a room like this, let's say this is a 3D model, a highly detailed BIM, but it's not, it's a photograph. And you asked AI, how is the wastewater from this bathroom handled? Well, AI will look at this image and say confidently, the wastewater flows through the building, plumbing into the municipal sewer system, and is transported to a wastewater treatment plant. And that's not a wrong answer just from the information that we have, but it's absolutely the wrong answer for the PAE building. This is not what's happening here. One example, this is a composting toilet that goes into compost bins, that goes into a system that composts the waste, and then what happens after that? It's sold as plant food in the lobby. I was blown away when I walked into the PAE building for the first time. This is actually there. I thought it was just a nice image, but the business driver of why are you doing this as an owner of the building to sell compost? Is that your business? No, you're showing how advanced this building is. So there's a reason for every building, and the building's meaning is usually lost after the owner or the construction finishes. So we're seeing this as an opportunity to capture this. And Stephen's going to walk us through the bigger story of why the PAE building is a living building. Why is it doing this composting? What's it doing with energy? And what were your challenges even though you had an advanced building, what were the challenges? So thanks, Stephen. So I'll switch over to you now.
That's great. Thanks, Kimon. Yeah, there's no such thing as waste in a living building. So my name's Stephen Lothrop. I'm an electrical engineer at PAE. Got my start in utility work and then microgrids and now smart buildings and AI. And I'm hoping to walk you guys through our journey through all this. So we designed, built, and work in this building. You know, we designed it to be a very smart building. It's won awards for being one of the smartest buildings in the world, but the status quo isn't enough for AI. You know, even though we have all these pieces together, everything's trapped in silos. We can't get it to communicate together. And so that's what we've really been working on this past year and a half, trying to break down these silos and use open source systems based on the Linux Foundation to really bring all this together. So we're going to walk you guys through what that journey has been like for us. A little bit of backstory about the PAE Living Building. It's downtown Portland, Oregon, in a historic district. We designed and built it along with ZGF Architects. This is a developer-led living building, fully pedal certified. That means really low EUI. We've got solar on the roof. We've got a battery in the first floor that is offsetting our demand charges. It enables us to have a microgrid. So should the utility go down, we can operate independently. As Kimon said, we've got this vacuum flush composting toilet system. No such thing as waste in a living building. So 58,000 square feet. Oh, also we capture rainwater on the roof, store it in a 71,000 gallon cistern underneath the building, and we process that, treat it on site, and use it. So we are connected to the city water, but we don't use it. So a lot of systems, smart building. We've got CLT construction. We've also got this concrete core that acts as that thermal battery for us, storing up energy when we need it, releasing it back into the building. Also a seismic resilient core. You know, our building's meant to last for 500 years. You can't be a really sustainable building if you're planning on rebuilding it every 25 to 50 years. So we want this to last a really long time. Okay, a couple of shots of the interior. We've got that seismic resilient core, the CLTs. Down below, that's a picture of our water system. That hatch you see is the one of the entrances into the cistern, water treatment, batteries up in the right-hand corner. A lot of different systems. And we were the engineers of record, so we should know where every single thing is. And then when we went to go get that data, we realized that even though, yes, we knew, it was scattered all over the place. It was scattered, not physically in this file cabinet, but on our computers and drives. You know, the status quo in the industry is we are trying to get the building built. We're not necessarily designing for this operations and maintenance, this central information repository. It just doesn't exist in the industry right now. So we take that Revit model, all that design knowledge that we had, the 3D connected systems, flatten it down into PDFs, deliver that to the plans examiner, and we've lost a lot of information in that process. And then we file it away somewhere safe. So we lose a lot in this standard process that is industry-wide right now. And a lot of the problem comes because relationships aren't built into these documents. We infer them as we read them. We use our architectural, engineering, other expertise to create those connections in our documents. They're not built in as much as we might think, and our computers can't read them. And I think this slide, the little image on the right, the AI generated sort of conspiracy theory board, does a really great job of illustrating this, because we can see there's one node in there where there's no thumbtack holding together a corner. So the AI got it partially right, but it didn't quite figure it out. We can't rely on AI to solve this problem for us by just throwing all our documents into this AI LLM blender and hoping for the best. We need something better. We need a checklist, a new database, a new type of format that we can put our building information into and have AI give us the relationships we need out of it. And so what we've been developing with SkyCentrics, Onuma, the Linux Foundation, is this concept of a knowledge graph, this interconnected web of all these nodes of information. And this is something that AI can help create for us. We can put our documents into that and use standard languages like ASHRAE 223, the BRIC ontology, Project Haystack for semantic tagging, real estate core. All of that gives us the standard checklist of what we should be putting into this semantic model. And it's all interoperable. We're not designing one standard, one file format that everyone now has to use. We're creating this substrate, this foundation that we can all build on top of together. An open knowledge base that everyone can build on top of together. This is what AI needs to be really useful in the built environment. This is the new deliverable of the AI age for buildings. So let's dive into the knowledge graph just a little bit, then I'll hand it over. So we've got our bathroom here that we looked at before. And of course, we have composting toilets, so things aren't going into the sewer. And off that, we have a rec bathroom. That's that ontology, that's the definition. Instead of our AI inventing what the definition of a bathroom is, that is defined in this dictionary of real estate core. And then down below, you see S223 luminaire. That's another dictionary. That's the ASHRAE dictionary. And that defines what a luminaire is. And so now if our computers ever want to reference what these things are, they go back to these shared dictionaries. So we all have a common understanding of our buildings. We're not inventing these terms. And now our AI can really understand our buildings in a way it's never been able to before. With that, I'll hand it back over to Kimon.
Thanks, Stephen. So what's interesting, what you just described, first of all, there were many systems in the PAE built, really advanced systems, but they weren't talking the same language. And what you have on, you left us on screen here with is there's a lot of technology in the background, which is important, but not all of us need to understand it. We just need to rely on it and ask it questions, because if you use AI, you don't say I'm using 223P and this and that. You just ask it a question, and Tristan's going to show a great example of that later. But I'm going to go back to my watch. If I had a watch and I was trying to call you and we didn't have a standardized phone system, I would be pulling up PDFs or phone books or whatever, trying to find phone numbers. In today's world, we expect this technology to allow us to connect. And the way it connects is because there's a standardized ID. It's very basic. It's what do we call that thing? What's the idea of it? Do we agree that that bathroom is room whatever, and there's something going on in it? Once you have that in place, then everything is possible. Before that, it just creates confusion, and that's the status quo of the industry. And the other thing relating to LEED 5, which we'll show later, this is exactly what LEED 5 and other metrics and analysis need. If you say, are we LEED version whatever, I mean, platinum level or whatever, it's going to ask, well, are these things working? And if you don't have the actual data, you're pulling documents and trying to prove that with documents. So that's the exciting part about this. It's shifting things that we're already doing as an industry into machine readable data to give us more time for the stuff that needs more interaction, more design, more creativity. So BIM has value, like you saw, but a lot of BIM gets delivered in the wrong format with wrong IDs, with no consistency. And the other thing is buildings are not static. They're constantly shifting and changing. Everybody thinks of a building as once it's done, we put the plaque on the wall and it's done. No, people change, equipment change, even owners change. So if owners change, how do we get access to that building? And the PAE example is just amazing because PAE is open sourcing this approach. They're saying, okay, we had some mistakes that happened before. We're going to fix that, and we fixed it. And now we're going to use this going forward. And we're sharing how we did that with the industry so others can do the same and we can lift everybody up together. So there's a lot of technology around all this to make this happen. So yeah, that was the building. And, so what happens with BIM is the design intent. So before a building exists, PAE said we want to have a living building and we're going to have composting toilets. We're going to have zero net energy, zero water, and put a swimming size pool, Olympic size swimming pool in the basement. So even before a building exists, there's the design intent that then gets carried out in design that then ends up in the physical building. So what you're seeing here on the left side is design intent and BIM going into a building, going into the actual digital twin. And this building, by the way, is open source and available online, which we've been using as testing, and it's mimicking the PAE building as well too. Then when you're going into measuring the building, we want to measure, did this building meet LEED version 5? We want to measure it, what level of maturity is this a digital twin? You want to know the initial intent versus the building here. Why is this toilet going into compost? Well, there's a reason for that. If you don't know the reason, then it becomes very mysterious. And it goes for all the systems in the building. And in the PAE building itself, there was a Revit model, like Stephen described. There was a lot of geometry, a little bit of data, not enough data. There were Excel schedules and PDF wiring diagrams for electrical systems. We took that, we brought it into what we call Cloud BIM, which is our system, the Onuma system. Other systems could plug in there as well. And we identified 3,000 assets that are important for operations. And then those lines that Stephen showed, the lines between the bathroom and the systems and the lights and everything, in this PAE building, we're up actually close to 200,000 what are called triples, relationships. A is connected to B, connected to the electrical panel, connected to this, and that's the cloud that you see on the lower right. Once you have a knowledge graph like that, then you can have AI ask it questions. So what Tristan's going to show, when you ask it a question, it's giving you a specific answer. It's not making stuff up and saying composting toilet is going into the sewer system. No, it's going here. Or how is the PV on the roofs and the battery in the building working together? It's not making stuff up, because as we know, AI can make stuff up, but so can humans. And we've been doing that for years. When we don't have good information about our buildings, we just say, well, it's probably doing this, or maybe this PDF is correct that I see from 5 years ago. But now with this accurate data, you can have a real conversation with the building. And we are doing that. So for example, the SkyCentrics data on the left is triggering this is the level of the battery, this is the level of energy in the building, this is the occupancy, and then it triggers an automated response that then color codes the room or color codes the cloud BIM that then can trigger an automated work order. This is digital twin territory when different systems, many different systems are communicating with each other. Just like I showed on my watch, it's telling me things that are the heartbeat of the building. And here's a short video that shows some of that. So this is in the Cloud BIM system now with AI, now talking to the building. I'm pointing to a room and saying, this room is hot. And it's going through that graph and saying, here are the things of why it's probably hot. It's finding things in that graph and saying, here's maybe what you should check and the systems that are controlling this room. This is just through a conversation without even saying I'm in room 104. I'm using like if I'm on my watch or smartphone, it knows where you are in the world. Same thing here. Therefore, it's giving you a conversation. And if I say, is there time series data that I can have a conversation with? We're going to see Tristan show this in the Dream platform. Having data with the building, with the context and location of the building, just like the map on my phone when I'm taking a walk, it's measuring how many steps I'm doing. Here, without a map, without a location, you just have hundreds of thousands of points of data. So that's the opportunity of simplifying the complexity of a building to have a conversation, and all this complex interface kind of goes away. It could just be even an audio conversation eventually. You could just be in the building, and we've been testing that as well too. You could say, where is the nearest panel that I can shut off in case of an emergency, or where do I go to find the level of energy that this thing is using? And this is all driven by the open standards that Stephen described, the ASHRAE 223P, real estate core and everything. We're building off of open standards so we don't have to reinvent the technology, and it can plug and play into different systems that are completely different applications. But if we're talking that common language, my phone here, my iPhone here on this side of the world can talk to any phone in the rest of the world because we have this common calling standard, and the same thing with the internet. So essentially we're modernizing building technology to catch up with where the rest of the world is, with the opportunity of the massive amount of data that's already there to take the information that's delivered in construction, move it into operational cloud BIM, which means now it's live, it's day-to-day things are shifting and changing, room names are changing, new equipment comes in, have that semantic model in the middle, that cloud that we showed with all the points, and then having operational verification with time series data from SkyCentrics and the Dream platform related to that space, so we can see the pattern, so we can do this kind of continuous semantic commissioning as the building changes. We mentioned briefly the Coalition for Smarter Buildings and the Linux Foundation. There's a lot of other groups involved with this. We don't have to know everything about what everybody's doing, but that's the beauty of having open connectivity. You can have different groups that are saying, we're focusing on agentic AI. There's a whole group on agentic AI, another one on trust, another one on digital twins, another one on a lot of different things, finances, whatever. It just goes on. And the Linux Foundation has a lot of other groups that have nothing to do with buildings, but have a lot to do with the technology. So we're using the technologies that's out there and applying it to buildings. And that's exciting. Okay, so this is where C4SB fits into that stack. And I think I'll skip over this, but this is so this is the cloud BIM with the SkyCentrics data that I showed earlier, and Tristan's going to show the conversation that this is having with the building next. And Tristan, if you're ready, I'm going to shift it to you.
Great. Hello, everybody. Thank you very much. Thanks for all that, Stephen and Kimon. Exciting projects. And frankly, I think the one thing that we've been talking a lot in our latest meetings is about how these different graphs, these different visualizations, these different standards have yielded sort of a graph of graphs, the ability to talk to each other. So for example, Kimon just showed you how Onuma specializes in spatial relationships around the building. SkyCentrics specializes in connecting to devices in the building. We came from the utility space. Kimon, do you mind bringing up the deck again? And then,
that's right.
And then, you know, we put those two things because of these open standards and common ways of naming and labeling the data. It has meant that, you know, Kimon's done some pretty magical things of entering our data initially into a LEED 5 application. I think that's an exciting story. So again, because these we're putting everything into a way that computers can not only read the data, but also understand the context. It's allowing for rapid innovation to occur. So if you can go to the next slide. So again, we came from a utility space where utilities are really interested in connecting to devices and asking them to use more energy when the grid is inexpensive and full of renewables and other energy that's low cost, versus please use less energy when the grid is expensive and higher cost and more carbon intensive. So in that process of connecting to machines, we realized, oh, building owners like Stephen want to also see as much of those machines and data in a place that's, again, open, AI native from the get-go. So here's a couple of ways we connect. We take Linux computers. You can see that SkyCentrics Super Skybox there. That's basically an off-the-shelf Linux computer with cellular options. That makes it real easy to install. We have BACnet discovery and Modbus discovery automated. So you plug these next to the machines. Mitsubishi is an important partner, so all of their via their variable speed heat pumps for both HVAC and water central system water heating are easily available. We connect to any BACnet device, central pump, central plant, chiller, heat pump array. Next slide, please. And the applications that you get out of this are predictive maintenance, trending, analytics, all applications that have existed before, but bringing a Linux computer into play means it's low-cost computing, better, faster, cheaper, and a lot more open and available for different things to happen. So the data from the Super Skybox in the PAE building is already not only going to our platform, it's going to the Onuma platform. We're pulling from the Onuma API location data. It's also going to an eView platform that analyzes rooftop units. Stephen's building, the PAE building, doesn't have rooftop units, but we're just practicing sending the data to multiple organizations at the same time. So here you can also put a Super Skybox in as a supervisory controller for the BAS. Stephen has an automated logic BMS. We are pulling from those points as well as individual systems. And finally, it puts this AI native infrastructure on the OT network and allows us to use agentic AI and AI agents that we've built and deploy apps, Python apps, real easy open language that every university student and young people know, as opposed to the much harder proprietary languages of typical OT networks. Next slide, please. So this is a little bit of the architecture. Everybody will have access to this PowerPoint afterwards so that you kind of get a sense of what it's all about if you want to dig into the details. But the applications and outcomes is what really matters, right? Fault detection and diagnostics, runtime-based commissioning and maintenance, demand optimization on the utility side. Utilities have been frustrated with commercial buildings that each installation is a very custom affair with the old technologies. So now it's much lower cost to get into a building and make it grid interactive. And then microgrid orchestration. It's important to try and have technologies that not only see the HVAC systems, but now with newer systems coming online like solar and batteries, you really want supervisory microgrid optimization on all those systems. So if you go to the next slide, you can see that, I apologize, actually, yeah. So you can see that we take photos of the building equipment, so that makes it real easy to onboard. The AI agent that we have can read the photos, it can read the documents, the as-built, the mechanical, electrical diagrams. So that's this vector store that you see. Then the live data is in real-time telemetry. It's in a modern database called DuckDB that's incredibly fast. And then the knowledge graph is the context that Kimon was talking about. This is a very common methodology used in other AI systems like at Meta and other places. And it's it allows the AI agents that you have to be able to query the building and understand the connections and what's going on. And I think that's what I've been asked to do live. So there's a little screenshot of a live interaction with the building. I'm now going to take over the screen and show you that live. So this is the live of the PAE building. As you can see, the PAE building over on the left side. This is the document section, so you can see that there's as-built assets. If I click on the assets, you can see the various items. There's pictures there. There's the battery room, the hydronics room, the Lochinvar heat pump water heaters, the Schneider microgrid. So these are the different assets. There's submittals, electrical drawings, mechanical drawings. So if I go up to our little AI Sparkle icon in the top right, it opens up an AI window. Just so I don't fumble finger, I've pre-typed the queries. So I'm going to ask a simple question initially. I'm trying to investigate the make and model of the water heater on site. So it's going to tell me that it's a Lochinvar. The model is this CHPA, the serial number, and this comes from the water heater nameplate photo. It gives you the sources and little links to the sources. So if I go to this first link of the nameplate photo, what I love about this is that it read the serial number, and I can read the serial number. But over here in the fuzzy is much harder to read text, but it figured out what that text was, and it tells me the model number. Then it says the electrical drawings also list this, so I can click on source 2, go straight to the as-built. So you can imagine that if you're loading pictures of your building and the equipment and all of these documents, I can scroll down, I can zoom in and see the details and make sure that the answers from the AI, if I suspect anything at all is not correct, I can investigate that with those quick links. I apologize. So I'm going back to a next question. So the serial number of the water heater, again, you're troubleshooting, you're investigating. So it says it's the same source as before. Now I can say, well, gee, I want to know what live telemetry points are available from that water heater. So it asks, I've asked at this PAE living building, the skybox that's in the building, what live telemetry points are available. I'm curious to know whether I can get data. So it told me that these points are available. And now I'm interested in a much deeper question, which is describe the interactions between the solar panels, the battery energy storage system, and the whole building's energy use. How could it be improved? So now, the most important thing as this loads up is not what we're necessarily doing right now, right? Where we want to get to is this question starts heading there. It's buildings that are better managed, easier to optimize, easier to check in on things. And eventually, that's what we got with cars, right? Our cars have more sensors. The dashboards tell you when something's going wrong, like your tires are a little bit low, and you can fill them up instead of having a blowout on the highway, which costs a lot more. So this kind of analytics has historically existed, but it's a lot easier and less expensive now. And again, with these open standards, that lets us do a lot more. And what's the end game in the car industry? Well, it's autonomous driving cars. But of course, they started off with a few years of what we would call human approved. There was a driver in the car at all times. And then we went to Waymo because we started having confidence in the autonomous capability of the computer. So that's where we're heading. So what did it say? The site is set up as a grid-connected microgrid, so there is solar. How could it be improved? I'm going to skip to that section. Keep the battery above the 35% reserve with more margin, so it can be during solar hours and absorb the midday PV without quickly hitting operational constraints. Use predictive dispatch, forecast the PV and building load, and then pre-discharge economic energy before high solar periods to create that headroom for the PV capture. And at some point after this, maybe Stephen can comment about, what he's seen. Has his microgrid battery controller system been able to do all this, or would this be useful for him to ask the battery people to potentially reduce controllable loads during export constrained periods, but only after the battery system is maximized to avoid PV curtailment. And finally, verify that the whole building meter is from the schedule before turning against telemetry. But it says I haven't verified that specific dream telemetry point, so I wouldn't use it to control conclusions yet. So I can say, please verify the meter point. And again, right, we've written our agent to be cautious and not say things that are incorrect. So it said, hey, I'm not sure if I verified the meter point. So I'm saying, well, can you verify the meter point? So it says, yeah, I verified it. The best point is this EM 101 data point. It tells you its reasoning. The building shows this. Downstream, the field photo labels it next to this. So it has a photo it's reading, and the dream telemetry has matching live points under asset EM 101. So I'm going to stop there. I'm going to go briefly to one other part just to show you what the AI can do in terms of generating reports. So I'm going to say generate a report of the last 7 days of QAHV power consumption. Now, this is a Mitsubishi variable speed water heating central plant. It's not in the PAE building, but for this demonstration, we put it in the PAE building. And so one of the things that you want to quickly analyze is to see graphs and generate them. So I can open this graph, and this could conceivably be available on the internet. I apologize. I wanted to do the preview so that you just see it right here. So it quickly generated a graph. It's live. You can explore things. You can zoom in on things. And the operating context is down there. And so now that I've done that, I can say, well, what portion of its energy was consumed between 4 and 9 p.m.? Because that's when peak demand charges occur. so I can ask that. And basically, I've been querying the building. So, Stephen, out of everything I showed, is there anything in particular that stood out that you've experienced that where some of this was useful?
Yeah, I want to say, we've been using this data in practice, and we've used it to reduce our demand charges pretty significantly. Before we had these systems installed, we had a peak of, I don't know, 120-ish kilowatts. Now we've got it down to 60 kilowatts. So sliced it about in half by really paying attention to our loads, having that data available, and that provenance, being able to see what the sources of the data are, really builds that trust and makes it something we can rely on. And I think one thing we haven't showed here, but is really amazing about the platform we're using, is that we can put, and I think Tristan mentioned this earlier, we can put our own apps to use this data onto the Dream platform using these Linux Foundation technologies. So this data is not siloed and locked down in one place. It's something everyone can use and build off of. You can build your own app. You can work in the SkyCentrics platform. They've provided an amazing amount of access. And that's because we're trying to make this open and interoperable and break down those silos.
Yeah, thanks. And on that peak demand charge minimization, right? So again, this is just the beginning, as Kimon said. Now that we've got this AI native infrastructure for buildings rather than the old proprietary, hard to work with systems, the apps are not only being able to be written by Stephen, but more and more players can interact with this process and say, oh, I want the data pipe from SkyCentrics. Oh, I want the cloud BIM and visualization of locations from Onuma. I want the rooftop analytics from eView IoT. And so the app innovation is just going to explode ideally to help everyone manage buildings, everything from data centers to school districts to hospitals. They all have unique aspects, but they're all buildings. They need hot water, hot air, cold air. And so there's a lot of similarities. And that's what we're trying to build is the infrastructure that enables all this. And with that, I'll go back to Kimon.
Yeah, and you make it look so easy. And I want to just stress how amazing this is because we have so many different platforms talking to each other. And imagine the day when we used to have a Pac Bell phone or an AT&T phone to even get on the phone line. And now we basically switch between different hardware and software and we open up our phones. There's tons of apps, which is essentially is what we're talking about here. Being able to build your own apps on top of platforms and not have to start from scratch and create them in a proprietary way. And the only way to do this is to be open. And to switch over to Zahra now, I think one thing that's important as we're building all this is how do you measure it? Because there's a lot of noise out there about systems that are, we have a single pane of glass. Well, it's their single pane of glass. You have to buy into their system. It's not really open. So you have to ask the right question as an owner. How do I really buy into a system that's truly open? And Zahra, along with NIST, and I was contributing as well too, we have put a paper together about maturity. How do you measure maturity? It's basically a metric. Zahra, why don't you jump in and tell us that story? How do we measure
Sure.
this building?
Yeah, great. Thanks, Kimon. I'm gonna share my screen. So, as Kimon mentioned, we worked on this project to build a digital twin maturity assessment framework for the built environment, and it's meant to be both for vertical and horizontal. And I think Tristan mentioned a little bit about the autonomy, and we know the different levels there. I think the single score works for cars, but the built environment is much more complicated. So there were existing frameworks that just had like one score for the whole digital twin of the built environment that went from informative to fully autonomous. So like 5 levels. But that doesn't really help the building owners. And we can't improve what we can't measure. So we developed this extensive framework, and it has 4 domains and 22 dimensions that I will get into. But the whole idea is that there is no single score for your building digital twin. There are different dimensions, and each dimension is scored separately, and it's meant to give the owners an objective tool so that they can create a roadmap and go from where they are to where they want to go in terms of digital twin system of systems maturity. We will release the paper. It's under review, but once it's approved and published, we will make it public, the paper, as well as the whole, we also have a spreadsheet that you can use easily to see how mature your digital twin is. Like I said, there are some simple maturity frameworks, but that's not enough. You can't take a measurable action based on that. What we developed, these are the 4 domains I mentioned earlier. So the first one is core digital twin capabilities. I'm not going to get into each of them because of the time limit, but it's different technical sides of it. So how well the digital and physical environment are synced, or how sophisticated your visualization and user interaction is, and how well does your system maintain the information as the building goes through different phases. And for each of the dimensions, there is a score from 1 to 5, so each of them get a separate score. And then there is the semantic federation domain. So there's different dimensions here as well, and I think both Stephen and Tristan mentioned about semantic relationships and all that. So for example, live data integration is one of the domains, and we also wanted to have a specific dimension there for work order linkage and interoperability. And then we have the trust and reliability domain, how trusted is the data, and how has the system validated it, and what are the data governance practices that are there. And also sustainability and value and performance, which going into Greenbuild, sustainability is a big part of that. So how much your digital twin system of systems takes into account the sustainability aspect, and use case readiness is another dimension, and user or participant return value. So how much your end user gets from your system, and also we want to have their feedback into the system as well. So again, for each of the 22 dimensions, there is 1 to 5 scores. So, and the idea is that you read through the definition for each of them and decide based on the evidence and the data what level is each dimension for your system. And then based on that, there is a current score and desired score. So after you score your system, your digital twin system, then the building owner can then sit and say that, oh, we are, for example, at level 2, but we do want to be at level 4. So what are the gaps? What are the next steps we need to take for that? First of all, I wanted to thank PAE engineers for giving us their data and letting us tear this apart and use it as a first test case. So we used the data, and this is the first pass. based on the data and information that we had. So we gave scores to each dimension, and this is a graph that shows all the dimensions, and it's not about, obviously PAE is the leading building, and one of the most advanced ones, but it's interesting to see that like there is a variation of scores, and for example, interoperability and lifecycle integration, they have one of the highest scores. But for example, use case readiness has score 3. So again, this is not about having a single score for the whole building, and it's for seeing that and visualizing that and seeing how we can get to a more advanced and more federated model. And with that, Kimon, did you want, since you were involved in developing this, did you want to add anything to it?
Yeah, I think this is still early on. Obviously, it's not publicly released, but it's going to come out soon, and we'd love to have others test it. And I'm going to go into the LEED version 5. It's related to LEED version 5, but it's a different kind of metric. This is a metric about the capability and maturity of the systems to be able to talk to each other, which quickly kind of isolates things that are proprietary and closed. So, for example, if one of the systems in the PAE building cannot be accessed, we can't see the time series data, then it just gets identified. Okay, and it's not a perfect world. It's all kind of whatever shows up, and the maturity increases over time. And so we'd love to have input from others as we start testing this more. There are some questions in chat. You guys, maybe you can read it, and we'll come to it after I finish up here. There's some great questions. I don't know if we'll get to all of them, but we could answer them later. But so I want to shift over to LEED version 5. We're not experts at LEED version 5. We actually jumped into it just like that and said, okay, it's online. We see the checklists. We see the information that's out there. We see that it's published on the Greenbuild site, and we decided to take that and turn it into a knowledge graph, essentially. This is basically the LEED version. It's actually building up here, but these are all the different requirements. And the reason we did that is if we use it like this, then just like Tristan showed and Stephen mentioned, if we have a knowledge graph about the building and the dream platform, then you can start comparing it against the LEED certification levels. So this was an experiment, and it's still in development. But what we found is we put the PAE building through, and it's just the first test, and we're going to continue here, so whoever wants to try it. So what can a building designed before LEED version 5 came around tell us about LEED version 5 today? We essentially are going back in time and taking the PAE building and applying it, because LEED version 5 also has it for existing buildings, operations, and maintenance. So we took the PAE data, and the interesting thing is we didn't not have to go through and checklist things. We basically asked a question and then filled in the chart and started having a conversation between the LEED requirements as a knowledge graph and the intelligence coming from the building, like we saw Tristan show. So imagine this equipment is speaking to us now, and one of the requirements from LEED 5 is that you have to have 1 year of metrics after the building is complete. This is our interpretation of it. We might not be completely right, but once you have this data and you have it for a year, you could say, yes, we've had it for a year. Therefore, we know that it's performing to this level, and we can say it's LEED version 5 to whatever level it is. And this is fed from all the data that we saw earlier from SkyCentrics, from the Cloud BIM, from the Onuma system, from what PAE has and other systems as well that are still increasing in maturity, and also looking at the intent of design was a score of 84 out of 110. This is not scientific yet because we just did it quickly using AI too. And what's it currently performing at? It said 6. The reason it says 6 is because we don't have 1 year of data yet. We're at about 9 months from SkyCentrics. I think once we hit 1 year, this score will naturally go up. And then, Stephen, you also have other data that is not yet in SkyCentrics. So if we combine all that together, the score would definitely go up. But this was kind of an automated version of what it thinks is happening. So it's about maturity of, we already covered the digital twin, so I'll skip over that. But digital twin maturity, as Zahra mentioned, is those sections. And if you combine them with LEED and you combine them with all the other capabilities that are out in the industry relating to BIM, relating to what we talked about with operations and maintenance, And we have another paper that's going to be published. Zahra and I wrote this paper on the semantic bridge, which is a bridging mechanism between different standards. And you saw it in action here. We don't have to have it in one monster standard. We basically can start saying, go and find this information from SkyCentrics about time series data, associate it with this space, put it on my watch, put it on my iPhone, show me how it's doing, have a conversation with it like Tristan did, give me some red flags of what I should be looking for, and alert other AI agents to go shut things down or turn things off, or send an alert to Stephen. We need some people in the mix here. It's going to dramatically increase efficiency. If it's done correctly, it's going to dramatically reduce effort. It's going to dramatically reduce risk. That's the intent, but it's going to take, we have to be deliberate about it to make it scale. And the most important thing to scale is this open approach that we talked about, to make the data sustainable and useful. And just as a quick summary, we started by talking about a single building, but imagine 20 buildings or 200 buildings or 2,000 buildings or a campus or a city. The way to scale is we all have to somehow have that same ability to have similar phone numbers that we can share. Even if it's a different building, even a competitor's building, if it's wanting to tie to the grid, there's going to be a way to tie to the grid and have a conversation with the grid. And we don't have to reinvent the wheel. We don't have to know all the technology. We just have to have that deliberate need and the owner's drive to say, let's make this happen. And it's really a group effort. And we believe strongly that owners are going to drive a lot of this conversation too. We're doing something called Become the Building at Greenbuild, which we are having 2 or 3 exercises a week, workshops doing this, including this lead 5 that we just showed, but a lot of other exercises, including cybersecurity. I saw there was a question about cybersecurity. NIST is involved with taking that exact building that I showed earlier and saying, what would it look like from a cybersecurity angle to protect that building? So anybody can join this mission. There's a QR code there. If you go to bimstorm.com, you can see what's going on. There's events every week leading up to the October 20th date at the AI Summit, right before the main Greenbuild session. It's a full day on AI, and we will all be there showing what the result of all this was. So, okay, I think we're at the end here, but we'll go to the questions. Do one of you want to jump into any one of the questions specifically? We have 7 minutes, so we can go quickly, I guess.
Sure. So the first one is this AI troubleshooting process, which is probably what I showed, meant for the facilities person, and is it built into the BMS system? So the platform is meant to have collaborators. Obviously, an engineering company, which historically has been a specifying engineer, MEP, or architects, have a lot of expertise, and now they can be brought in for interesting problems as a collaborator on the operations of the building. The facilities person, as you know, some facilities people have a lot of expertise. Sometimes they outsource it to service providers. So the idea is that you want to get these kinds of tools in the hands of the right people. So sometimes that will be a facilities person where they can make sense of it and explore. Other times it may need to be the engineering company that has more expertise, or the service providing company. Is it built into the BMS? So as I said, Stephen has a BMS at the PAE Building. We are getting data from that. We're able to write points to it. At some point, we've been exploring some supervisory control to be able to automate some of those results that Stephen mentioned, like reducing peak demand charges. But we're not changing the BMS. We're just a layer on top of all the systems, delivering the data from all the systems. And one of the things we've just started doing at the PAE, because it's a reference building, it's already a world famous building. It's becoming more famous now because of all these things that we're doing. And so we've just shipped Stephen a new box that can handle all 25,000 points of the building and start to do significant analytics on that, but we're not changing the BMS, so to speak. Stephen, do you have any follow-up on some of those thoughts?
Yeah, and I think the computer that we're putting in is going to be a lot more powerful than the BMS computer. So we're putting in this modern Linux-based computing platform, and that ties into the cybersecurity question. Is now we have this modern compute platform that's the same kind of model done in data centers. So I can put my app onto that SkyCentrics platform, and the securities are taken care of on the platform, so that my app can't just reach into the BMS or any other system and start changing points. There's a security layer built throughout. There are multiple security layers built throughout. And so that's the advantage of moving towards this Linux-based approach versus going with putting another app on the BMS, where those cybersecurity things, that sort of app layer, isn't really built out. The BMS is not designed for that.
Yeah.
As a friend of mine in the OEM of a BMS said, you know, we've typically been internally focused. Yes, we can sort of go outbound to the internet, but it's not what historically it's been built for, as Stephen said. But meanwhile, Linux took over the whole internet world and the servers of the internet because it was an open operating system. So it wasn't cybersecurity by obscurity. So, you know, a lot of times BACnet worked really hard to develop BACnet SC, Secure Connect, but it often means having to replace controllers and supervisors. And now you can put a Linux computer that's got all that built-in cybersecurity, not only sort of for the internet, but as Stephen said, you know, we're using Docker containers, Kubernetes, all these modern tools that have been built around allowing people to do apps and be interoperable without breaching cybersecurity. So I think that answers the cybersecurity and the BMS.
Yeah, there's one more
Kimon,
angle.
do you want to take one? Yeah.
Yeah, since we're talking about cybersecurity, from a maturity perspective, NIST is actually involved with a cybersecurity angle on this, and they're doing testing on this very building. And NIST is a co-author on the maturity framework with Zahra and me too. So I think from a maturity perspective, once you have mature data and systems, then a lot of different use cases come out of it. You don't have to create a separate silo to say, now we want to do cybersecurity. It's all kind of related. We want to find that box that's doing this in the building. We want to be able to have, there's a question about redundancy, and you can have redundancy if you're not dependent on one system and there are overlaps and you can quickly unplug one and plug another one in. If you're trapped in one system, then you're kind of reliant on that one vendor and you have to wait for them to build up their capability. That's the way that this all scales. Zahra, do you have any comments on the maturity angle on all this? Because I think maturity runs through all this as well too, but cybersecurity or access, relationships, all that is kind of an important piece of it.
Yeah, I think it touches on some like several dimensions, and the whole idea of like the framework is to consider all of these attributes and dimensions together, not in silos. So I think it's very interconnected.
Yeah.
Let me just finish, Kimon, because we don't have time. Can you discuss the added sensors and redundancies? I just want to say one thing that's pretty funny, right? So the new skyboxes we shipped to Stephen are 3 of them so that they provide N+1 resilient supervisory control. So the IT world is used to N+1, right? You do 3 things so that if one breaks, you still have 2, you have time to fix or replace the other one that's missing, and you're back to having 3. And Stephen laughed when we proposed that a few months ago because he said, oh, that's pretty funny. Nobody's ever, that I know of, put 2 BMSs in and 2 lighting control panel boxes in because they're expensive, they're hard to image, but a Linux computer can be imaged and replicated. And so sensors and redundancies, yes, of course, but at least that's a lot easier with low-cost, off-the-shelf Linux computers than with the historical stuff.
Yeah, and with that, we're at the top of the hour. I think this is great. We're going to have follow-up on bimstorm.com/AI. There's some questions we didn't cover, but we'll certainly put them in the workshop. And we look forward to seeing everybody at Greenbuild and at other workshops. Thank you, Greenbuild, and for this session. And
Awesome.
thank you, everybody, for participating.
Yeah. Awesome.
Yeah.
We are right at the end of the session, so I'll keep the wrap up pretty brief. Thank you again to our speakers for a great session. This webinar will be recorded, and the recording will be available on the webinars page of the Greenbuild website. Okay, thanks everyone, and we hope to see you next time.
Thank you.
Thank you.
think so.
Bye.